Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Step 1. Formation of a cyclohexene reacts with NBS, N-bromosuccinimide, via allylic bromination to give 3-bromocyclohexane. Treatment with Ng ether converts this to a Grignard reagent, 3-cyclohexanyl magnesium bromide, allylic Grignard. The Grignard reagent exists as a resonance delocalized allyl Grignard, meaning the metal can be at C1 or C3 of the allylic system, but effectively gives 3-cyclohexanyl magnesium bromide, A. Step 2. Formation of B. The Grignard, A, reacts with isobutyraldehyde, HC, is equal to O, CH, CH3, 2, in the presence of ethyl bromide, CH3, CH2Br. The Grignard adds to the aldehyde to give, after workup, a secondary alcohol. The product is 1-cyclohex-2-N-1-Yl, 2-methylpropan-1-ol. However, rereading the reagents, the aldehyde shown is HC is equal to O, CH, CH3, CH3, which is isobutyraldehyde, 2-methylpropanol, and CH3CH2Br is ethyl bromide. In this reaction, the Grignard reacts with the aldehyde. The ethyl bromide serves to quench or is part of a two-step sequence. The product, B, contains a cyclohexene ring with an attached carbon-bearing OAT and 2 methyl groups. This suggests the aldehyde reacts with the Grignard, then etherification or the ethyl bromide alkylates the resulting alkoxide. The alkoxide formed from Grignard addition to CH3 to CHO gives CH3 to CH-CHO- cyclohexanyl. Treatment with EtBr alkylates the oxygen to give the ethyl ether CH3 to CH-CHO- cyclohexanyl. But the product structures show a quaternary or tertiary carbon-bearing OAT and 2 methyls directly on the ring carbon, suggesting the Grignard adds to give a tertiary alcohol carbon attached to the ring. Actually, the Grignard, cyclohexanyl-MgBr, adds to isobutyraldehyde, Me2CHO. Product alcohol is Me2CH-CH, cyclohex 2N1-Yl alkoxide plus EtBr Me2CH-CH, cyclohex 2N1-Yl. This places a CH, CH Me2, substituent at C1 of cyclohexene ring, giving B as 1,1-ethoxy 2-methylpropyl, cyclohex 2Na. Step 3. Formation of COSO4H2O2 performs S1 the hydroxylthione of the double bond, C2 is equal to C3 of cyclohexene, in B, giving a CIS diol. The double bond is between C2 and C3, so the hydroxylthione gives CIS of groups at C2 and C3. Step 4. Stereochemistry analysis. The substituent at C1 is CH, CH Me2. This carbon, exocyclic, bears H, and the isobutyl portion, it is a chiral center with 1 H. The OSO4 dihydroxylthione adds 2 of groups SYN from either phase. The key question is whether C1 has a quaternary or tertiary, with H, carbon-bearing OAT. Since the aldehyde carbon, CHO, becomes CH, OAT, after Grignard addition and etherification, it bears 1 H. Thus the carbon-bearing OAT also has 1 H, matching option B, which shows H on that carbon. Option A shows no H, quaternary, which would require a ketone substrate instead of aldehyde, incorrect. The SYN dihydroxylthione gives CIS diol, both are on same phase, shown as bold wedges, matching option B. Option C shows trans relationship of the 2 of groups, which cannot result from OSO4, which gives exclusively SYN addition. Therefore, the correct answer is B. Therefore, the correct answer is option B.